Assalamu alaikum and a very good morning. This is Ansari Yasmin and today I have come up with a science video of Standard 7th chapter Heat. And today we are going to learn a very interesting topic, an abnormal behavior of water. But before understanding the abnormal behavior, first we will see what is the normal behavior of any liquid. Some of the questions which always click our mind is, here you can see an iceberg which is floating on water. So this question always click in our mind, that even though if it is in a solid form, why does it float onto water? Whenever we put any solid substance in water, it gets sink into it, but this iceberg is in a solid form and it is floating, it always float on water. So what is the reason behind it? One more question, if we keep any liquid in a bottle, if we keep it in a glass or in a bottle, and if the temperature goes below 4 degrees Celsius, of course it will turn into ice, and when it will turn into ice, the bottle will burst. So why does it happen? The same amount of liquid when we had filled up, the bottle was proper, but when it converts into solid, or when it converts into ice, the bottle burst. So why did this bottle burst? What is the reason behind it? So we are going to answer these questions today in the chapter Heat, under the topic Anomalous Behavior of Water. Let's first understand the normal behavior of any liquid. Here we have taken a liquid. It's not necessary that we have to take water only. We are talking about, generally we are talking about any liquid. So if we take any liquid and if we heat it to a certain temperature, we all know that whenever we heat any liquid, of course it will expand, its volume will rise, its volume will increase. Here you can see on the screen, the volume is increasing, it is expanding. So this is the normal behavior of any liquid. If you take any liquid and if you heat it, of course it is going to expand and its volume will increase. And on the other hand, if the liquid is cooled, if its temperature decreases, so it is going to contract. Let's see here. Here we have taken any liquid and we are now cooling it, and after cooling we will see, yes, here you can see the volume is decreasing, it is contracting. Okay, so why does this happen? This we all know that this is normal behavior of any liquid. If we'll heat, it will expand, and if we'll cool it down, it will contract. When we take any liquid at a room temperature, the molecules of the liquid, they moves randomly. Of course they will be having a kinetic energy, and because of this kinetic energy they are moving randomly. And if we have to calculate the density of any liquid, the density can be calculated by using the formula mass upon volume. This we have already studied in previous standard, that if we need to calculate the density, its mass has to be divided by its volume. So density is directly proportional to mass and it is inversely proportional to its volume. Let's see what happens when the liquid is heated up and when it is cooled down with these molecules. See, whenever we heat up any liquid, as you have seen the previous slide, where the molecules were moving with the normal velocity, but when we heat up any liquid, they gain kinetic energy, they gain more kinetic energy, they start moving faster and they start expanding. When we heat up any liquid, it starts expanding, and when it's expanding, it means its volume is increasing. Okay, and we had seen in the previous slide that volume and density are inversely proportional. So as the liquid starts expanding, as its volume starts increasing, of course its density will decrease. So when we heat up any liquid, its volume increases and hence the density decreases. Whereas if we will cool down any liquid, let's see what happens. Here you can see, when we cool up the liquid, it contracts, the molecules get accommodated at one place, its density starts increases because more molecules get accommodated at less place, so its density will increase. The molecules have contracted, they have accommodated at one place, so volume is decreasing, it is contracting, volumes come closer to each molecules come closer to each other, and hence the volume decreases. And as the volume and density are inversely proportional, volume decreases, so density increases. On the screen you can clearly see the difference when we heat up the liquid and when we cool down the liquid. When we heat up, the volume increases. When we cool down, the volume decreases. And as the volume increases, density decreases. And as the volume decreases, density increases. So this is the normal behavior of any liquid. Why did we learn this normal behavior? So that we can understand the abnormal behavior of water. But water behaves water is special, it shows a special and exceptional behavior, but it does not show this special and exceptional behavior at all temperature. This exceptional and special behavior of water is between 0 degree to 4 degrees Celsius. As we all know, when we heat up any liquid, it expands, and when it is cooled down, it contracts. But when the between 0 and 4 degrees Celsius, when the water is heated up, instead of expanding, it contracts. Okay, so at 4 degrees Celsius, suppose if the temperature of the water is 10 degree, it is decreasing. So if the temperature is decreasing, of course it will contract. Till 4 degrees Celsius it will contract. Then when it will reach to 3 degree, when it will go beyond 4 degree, instead of contracting, now it will start expanding. So at 4 degrees Celsius, the volume of the water is minimum. After that, the volume will start expanding. Here I'll show you one experiment. I'll show you through this graph that if we take 1 kg water, here you can see the thermometer is put into the water. 1 kg water has been taken, and when this water is heated up, let's see what will happen through this graph. Here you can see the temperature versus volume graph, where you can see at 0 degrees Celsius. So here you can see, let's see through this graph, that at 0 degrees Celsius the water is having certain volume, and when it is going beyond 0 degree, when the temperature will increases, you can see here the volume will decreasing, here you can see. And then at 4 degrees Celsius, here at this point 4 degrees Celsius, the volume is minimum, and after this again the volume will start increasing. If it will go to 5 degree, 6 degree or 7 degree, the volume will again increase. So from 0 to 4 the volume will decrease, then from 4 to 4, 5, 6, 7, if the temperature will increase, again the volume will increase. So at 4 degrees Celsius you can see here the volume is minimum, and this behavior between 0 to 4 degrees Celsius, this behavior between 0 to 4 is called the anomalous behavior of water. And what is this anomalous behavior? Anomalous means abnormal behavior. So here you can see the water is showing the abnormal behavior. 0 to 4, the temperature is increasing, and if the temperature is increasing, of course the liquid should expand, but instead of expanding, its volume is decreasing. It means it is contracting. Instead of expanding between 0 to 4, it is contracting. And then after 4 degrees Celsius, again it will show the normal behavior. After 4, it is going to show you the normal behavior. This abnormal behavior is seen only between 0 to 4 degrees Celsius, and this is the abnormal behavior of water. Students, I know everybody likes normal things, normal behavior, normal people, but here we have seen the abnormal behavior of water, and this abnormal behavior is also very useful for the survival of the aquatic life in colder region. This anomalous behavior or the abnormal behavior of water helps the aquatic life to survive when the temperature goes below 4 degrees Celsius. How does it help? What happens exactly when the temperature goes below 4 degrees Celsius in colder region? Why does the river, lakes doesn't all the water of the lake doesn't freeze up? Only the upper layer freezes and the water below the ice layer remains in a liquid state, and this is because of the anomalous behavior of water which helps in the survival of the aquatic or marine life. So that we will understand in our next video. Till then, bye, thank you, and always remember, everything is unique, everyone is unique, and we should respect the uniqueness of every individual or the every object. God has made every object with special characteristics. We should respect the uniqueness of each and every one and each and every object. With this thought, we'll take a leave now. Bye bye. See you. Thank you.